These are the notes for 4.3, solving quadratic equations. And so we know quadratics are equations that look like ax squared plus bx plus c equals 0. Okay? We know they're solved like that, or we know they look like that. Now this section doesn't quite fit that match, but I'll go into how it's different in just a second. But we also know that these sort of functions either look like this or look like this, right? The parabolas. And if A is positive, they look like this, and if A is negative, they look like this. So when we talk about solving them, we talk about finding the values for x that make the expression equal to 0. Okay, that's kind of what this says here. Finding that value for x that makes it equal to 0. And so if we think about that from a graphing standpoint, then we have to kind of consider this quadratic expression function y, or f of x. Let's call it f of x. I like function notation. F of x, right? Because it tells you what to put in for x. And so if we consider that from a graphing standpoint, that just means that we're graphing f of x on the y-axis, right? Here's the y-axis. And so we're finding those values when y equals 0. We call those x-intercepts. And because we have this sort of shape, I'm going to just draw it like A is positive. I'm going to just draw them opening upward. Because we have this curve, we have a potential to cross the the x-axis a couple of times. So for instance, if we would draw the parabola so that it crosses here and here, and I like this about notability, because you can draw pretty nice parabolas if you just kind of hold at the end. Then we see that it crosses the x-axis. It contacts the x-axis in two locations. Like it contacts at -3, and it contacts it at 1. And so those are the solutions. It's when, those two are the x-intercepts, that's when y equals 0. But really, it doesn't have to cross that x-axis twice, right? If we would take this parabola and duplicate it and slide it over here, we could put it anywhere, right? If we put it down farther, it would still cross. And, right now we're right here, but if we would slide it down, it would still cross in 2 spots, even if we went all the way down to here, right? Because those arrows means it goes up forever. But if we start putting it up here in quadrants 1 and 2, we could get it so that it just touches the x-axis in one location, like that. And in which case, the only point of contact, so to speak, is like right here. Let's call that x equals 4. And so we have one solution in this situation. We have 2 solutions here. And this one solution scenario we call a repeated root. Okay. But we still could move it up even farther. So let me duplicate that again. We still could, now we're right here, right? We still could move this up even farther. And I'm just going to, put it like maybe here. And now it doesn't contact the x-axis at all. So there's no solutions, right? The vertex is now here, And that's not a solution. It's not crossing, it's not coming in contact with the x-axis at all. So now there's no solution. And when we say no solution, we're implying something that I don't think teachers mention enough. But it's really no real solution, okay? There's actually a complex. The solution is complex. It's got the imaginary numbers, you know, the i's, like 3 plus 7i and 3 minus 7i. The solution is complex. So we call that no solution because we're usually talking about graphing it, and when we graph things, we're talking about the real number line, not the complex number line. So so we call that no solution when it doesn't come in contact at all. Okay, so let's go back to this general form up here. Notice it has three terms. It's a trinomial. It's got an x squared term, it's got an x term, and it's got a number term. And they don't all have to be on the left-hand side. But that does help for solving in most situations. Now, if you look at the problems in this this section, if you notice, they don't really look like that ax squared plus bx plus c equals 0, okay? And in fact, you'd be hard-pressed, except for on this back page here, you'd be hard-pressed to even find an x term, right? This example has an x squared and a number, but not that middle term, not that bx term, okay? Likewise here, we don't have the bx term, nor do we have it here, and nor do we have it here. And that's advantageous. It simplifies our solution. So really what we're looking at on this front page are solutions where we don't have to factor, right? We don't have to do like a star method or anything like that. So it greatly simplifies our solutions when we don't have to do that factoring. So what we can do then is we can, in this first page, we are going to isolate the x squared, and then we're going to isolate that x squared term, and like we do algebraically with almost every expression we deal with. So here's that x squared term. Then we're going to square root it to solve it. We're going to divide by 2. So we're going to divide by 2, and so we get x squared equals 49, and then we can square root it. And then when we square root it, what we get is an option of a plus or a minus answer, right? We can, when we look at putting our answer back into the expression 2x squared equals 98, we can put a 7 and square it and get 98, and we can put a minus 7 and square it, and that's going to be positive, and it's going to give us a 98 as well. So that's why we have here is our two solutions, so to speak. These are our two solutions. X equals 7 and x equals minus 7. Okay, so now what we're doing is we're just doing our algebraic strategies. So I'm just going to go through these pretty quick. So we're going to subtract 7. We're going to say minus x squared equals minus 43. We're going to divide by negative 1 because that's what this is. We've got x squared equals 43. And so x equals plus or minus the square root of 43, and you can just leave it right like that. You don't have to grab a calculator and give me a decimal if you don't want to. Okay, next example. Again, we're solving for x squared, so we're going to have to subtract 7, get that number over to the right-hand side. That leaves us with negative 8, right? We got a negative out in front of this term here. We can't forget the negative. Negative 8x squared equals negative 80. We're going to divide by negative 8. X squared equals 10. And so x is plus or minus, oops, I forgot my equal sign there. equals plus or minus the square root of 10. And again, you don't need to give me a decimal. Square root of 10 is good enough. Last one, minus 1, minus 1. So these are really very much the same algebraic strategies we've been doing for this whole unit. Divide by 2, I forgot my squared there. X squared equals 8, so x equals the plus or minus the square root of 8. Okay, and then, so now on this next page we're getting to be more complicated, okay? And, nope, there's example 5, okay. So we've got a fraction. That's okay, we're just going to multiply this whole thing by 3. So 3 times a third is 1, so I have x plus 5 quantity squared equals 21. That's what 3 times 7 is. And I have in effect isolated the power of 2. So at this point I just square root everything, and I have x plus 5 equals the plus or minus the square root of 21. And then I've got to subtract 5. And you can work on decimal and get 2 answers at this point, but this is the cool thing about these solutions. You can just leave this as minus 5 plus or minus the square root of 21. So that's 2 answers. That is minus 5 plus the square root of 21, and it's minus 5 minus the square root of 21. But if you left it just like this, that would be okay. It's just a way of writing 2 answers in the same stroke of the pencil. Okay, so 6 and 7 are really advanced problems. And it's really just extending your algebraic strategies, right? We're still looking to move that 45 over. Okay, so we get 2 times the quantity a minus 6 squared equals, and then when we add this we get 98, and then dividing by the 2, and so we get a minus 6 quantity squared equals 49, and now I can square root, and I get a minus 6 equals plus or minus 7. And this, since we had a perfect square right here, we can go ahead and get numeric answers for this by adding 6 to both sides. And so we get a equals 6 plus or minus 7, but really we should figure out what that is. 6 plus 7 is 13, and 6 minus 7 is negative 1. So those are the 2 answers. And then the last one is just working in a fraction, right? Just like the one above. Now we're going to multiply by 4, though. And 4 times 1/4 is 1, so that is just x minus 8 quantity squared. And then 7 times 4 is 28. And now we can square root that. And we get x minus 8 equals the square root of 28. Which is not a perfect square, so we're just going to go ahead and, this is plus or minus, we're just going to go ahead and add 8. And we're going to get x equals 8 plus or minus the square root of 28. And like I said, you can convert that to a decimal if you want, but you don't have to. So the homework then is on that starting on the next page. Just a reminder again that I give you the answers.